Okay, so we've got differentiation, and hopefully you understand that quite well. So whenever we've got a situation where something is changing, we want to figure out the rate of change, and we take a derivative. Okay, rise over run. And hopefully we understand that pretty well. So anytime we need a rate of change, we take a derivative. We've got the antiderivative, we've got taking an integral. That's going to occur anytime we have to add lots of things up which are changing. Okay, so the typical example is area under a curve. But there turns out lots of times where areas of the curve can be interpreted as adding something up. So that's what I want to talk about today, is this idea of surplus, producer and consumer surplus. So this is a really classic idea from economics, and it's one of the things they like to show you guys when you do economics. Just sort of like, you know, what are the benefits of having an open, free market? And so the idea is that if you have a market and there's no interference, then, you know, Adam Smith said something about the invisible hand, and that how the market will come to an equilibrium price and there'll be an equilibrium quantity. Okay, so that's good. And then this is how you then show that that's a good thing. That is kind of like, if a market reaches its proper equilibrium, so there's no interference from the government, there's no interference from the producers, you know, creating a monopoly to fix the market. There's no collusion among the buyers. What's that, a monopsony or something like that, when the buyers do that? So again, so that if there's just a free market where everyone can come in and express their wishes, and the market comes to an equilibrium price and there's an equilibrium quantity exchange, that is optimum. And this is how they explain that. So what happens is we have some kind of supply and demand curve, right? So typically, so remember, since this is a very old subject, they put it the price and the quantity, where in modern times we probably think of it the other way. But a good old demand curve could be something that looks like this. And a supply curve might look something like this. Okay, and so what we expect then the market to do would be to come to this equilibrium. Okay, now, how can we, so if we want to say it's a good thing, somehow we've got to quantify what that good thing is. Okay, and the classical way that economists do that is the following way. Here's a demand curve, right? Here is what the market tells us that the good will go for. It'll go at this price. But the thing that we notice is that there are people here, there are consumers who would have bought the good at a higher price. Okay, so for example, there's a few people up here who would have been willing to pay this really exorbitant price. And there's, you know, some people here, all waiting to buy those quantities. And so we can see that, so the Q, right, that's the number of people who are buying it. So this represents all those people. So that, for example, let's assume that the consumer is only going to buy one good, but that's not necessarily, you know, you're allowed to buy lots more, but whatever. So this represents goods that people are buying, and this represents the prices they would have been willing to pay. Okay, so if we cut up this thing into a little grid of points, like we like to do, you notice that we like to do that in calculus all the time. We like to cut things up into little grid of points. And we can say that for these goods here, we would have been willing to pay that much. For these goods, we would have been willing to pay this much, etc. Okay. So if we add up all the extra money that people would have been willing to pay, i.e. this is money above what the equilibrium price was, we see that adding up all that money is the same thing as adding up all this area. Right. We know that's an integral. This thing here is known as the consumer surplus. So it's how much money the consumers saved because there was a free market, because no one forced the price up high for whatever reason. Similarly, we can do the same thing with the producers, right? So they got this price. Some of them would have been willing to have sold it for a lesser price. So they gained money too. Everyone's getting money. We're all getting rich. Okay, and we can do exactly the same thing. Again, this quantity is like quantity sold. So that is goods that would have been willing to have been sold at a cheaper price. But they got a better price. And that better price is here. So the extra money they got, let's do this in green, is now these little rectangles here. Again, it's an area. So again, it's an integral. And this is a surplus. Who gets that? Well, the producers get that. Okay, so all together, we have this total surplus from that price. Because we allowed a free market, we allowed the market to come to this equilibrium price, and this is the total surplus. So this is all the money that was somehow saved because of that. Now, what happens if there is a different price? Okay, so I look for another color. Here's what happens. Red and blue. Okay, so what could we say? So let's say somehow, I know the government puts a tax on, or a monopoly is formed where they artificially put the prices up, or whatever. Let's just say we've got a new price here. Let's call that price plus. Okay. Now, what's going to happen at that price plus? Well, at that price, there's only going to be this much demand. There's going to be that much supplied. So here is where the market is going to be at. And so the point is, because they artificially raise the prices, that means they suppress the market. Okay, and so now let's have a look what happens. So now this is the price. And now let's have a look to see what happens to the consumer surplus. So what happens to the consumer surplus? It shrinks, right? And it shrinks to this amount here, to this area here. Okay. And so if I gave you this as a problem with graphs and it's got squares, you could count up the squares and you could actually figure out how much that consumer surplus. So is this a kind, have you done these kind of problems in? Yeah, okay, good. What happens to the producer surplus? Well, it actually goes up, right? Because now here is the producer surplus. It goes up. That's why they did it, right? That's why they did what they were going to do. They could, but consumer surplus goes down, producer surplus goes up. But what happens to the overall surplus? It goes down, and you can tell that, right? Because the original surplus was here. The surplus now is there. So the market is less efficient, and that's how they define efficiency. They give it a number. This surplus is the number they give to the market. Okay, and so what you want to do is maximize the surplus. To the minds of the economists, that's how you optimize the market. What happens if, you know, they put pressure on the government to lower prices, or you know, they get together and they force the price down? Well, if they force the price down, let's do P minus. What happens in that situation? Well, in that situation, the price has been suppressed. So what's going to happen? Well, the consumers want lots of that. Who are complaining? Producers. And from the supply curve, we see that this is what happens, right? Because this is how much, even though this much is demanded, this is much is being supplied. So we are, oh, it's exactly the same quantity as before. So this is also Q minus. In this situation here, we can see that the consumer surplus has grown a lot, right? What shrunk is the producer surplus, but the same situation, the total surplus is down. So that means that the market is less efficient, because that's how we're measuring efficiency, by the surplus. Okay, so everyone's noted, so everyone's kind of seen this before. Great. So what we're doing in this class is now we're just turning it into an integral problem, which is probably, you probably didn't use integral. Did you use an integral notation? Right, you just, what did you just say? Did you talk about the area, or how did you define it? How did they define it?
It should be done with a straight line, so you could just calculate that.
Because it's triangles.
Yeah.
Okay. Okay. Gotcha. So it's just, so you just did simple geometry when it was in an economics class. Okay. Well, with integration, that means we can do any kind of. So this is kind of like the theoretical. We can theoretically do anything. Okay. So that's the basic idea. So let's try and get this to work. Okay. So this is the basic thing that I showed you before. Okay, it's on the slide. Okay. So we're all happy with supply and demand curves. So here, and here is our equilibrium. So remember, P0 is kind of like the minimum price that you need for there to be a market, because otherwise producers wouldn't turn up. P1 is the maximal price that you can offer to have a market, otherwise consumers aren't going to show up. Q1 is the theoretical maximum demand for a good. So if the good was free, how much would consumers use? And P star and Q star is the equilibrium where the market should settle if there are no outside forces or disturbing forces or corrupting forces, or however you want to say it, right? Because we know that, you know, if the price is too high, then the suppliers will oversupply, and then they have to lower the price to get rid of that glut. If the price is too low, there's a shortage, and that shortage will drive the price up. So it's a genuine equilibrium. So here's the definitions of what things are. So this is what you would have done exactly something like this in economics. The consumer surplus measures the consumer's gain from trade. That's gain from trade. That was the important phrase. I think that's what got, you know, people like Adam Smith and that talked about gain from trade. It is the total amount gained by consumers by buying the item at the current price rather than at the price they would have been willing to pay. Okay. So this is the consumer's gain from trade, also known as a consumer surplus. The producer surplus measures the supplier's gain from trade. It is the total amount gained by producers by selling at the current price, rather than at the price they would have been willing to accept. So this producer's surplus, that's the supplier's gain from trade. Okay. So this total surplus, that's right, it's known as the gains from trade. Good 18th century term. Okay, and so that is what we look for in a market. So the best market is the one that gives the greatest gains from trade. Okay, and so this is what I explained before. And so, what we're doing is getting towards the mathematics here, right? And so we're going from the economics to the mathematics. So the consumer surplus at this price then is the area between the demand curve and the equilibrium price. So remember, the equilibrium price, that's a horizontal line, right? So that's just P equals P star, is this line here. And the producer surplus, right, is the area between the supply curve and the horizontal line at P star. And this is always the case, right? The demand curve is going to be above the price line. The supply curve is always going to be below the price line. Okay, so let's have a look at a particular industry. Let's say dairy industry. So dairy industry is infamous for having not a free market, right? Because dairy farmers form cartels, they lobby the government, they're a very powerful group. And so that's typically what happens is they make sure that the price is above the equilibrium price, And they can kind of get away with it, right? Because milk is, what is it? Inelastic or elastic? It's inelastic, right? People need milk, right? Basically. You know. So they can keep the price artificially high, and so they don't care that the quantity goes down, right? Because they can grab. So this picture explains it, right? Because their surplus goes up at the expense at the total gains from trade. So this is why it's in their interests to form a cartel and do this. Okay? And so this is the typical effect that when you get a cartel, they can do that so that when you rise the price, right, the consumer surplus goes down, right? It goes down from here to here. The producer surplus increases from here to this amount here. And the total gains from trade diminish from this area here to this area right here. So, of course, if you have an elastic good, you're not going to get that. It's not really in your interest because the quantity will go down and that'll start eating into your gains from trade. So you don't have as much to gain from doing it when you have an elastic good. Okay, and so this shows the difference between the consumer surplus at the equilibrium price and at the actual artificial price. Here's the effect in the producer surplus. It's going up. But the thing that we don't like as economists, as proto-economists, is the effect on total gains from trade. Right? And the thing you can see from this picture is that the equilibrium price is, we defined it to be where the supply meets demand, but we can also define it as the price that maximizes gain from trade. It's an alternative definition, right? Because any point besides that, any other price, right, will mean that a lesser quantity is traded, and it means that the gains from trade will be the area between the two curves to a lesser, there's a smaller interval in which we're taking the area over. Okay, so that's the important economic point. Did I? Okay, let's have a pause then while I turn the light on. And let's write out a mathematical thing. So the consumer surplus. Okay, so we've got a verbal description of it, but a mathematical description of it. If I go and find the right, so I guess that's the consumer surplus. It's going to be an integral. Okay, so it's an area, so it's an integral. So what do we got to do? We've got to know what are we integrating. What are we integrating with respect to? We always integrate with respect to the horizontal axis. So it's a dq. Now, the bounds of integration is going to be the interval on which we're taking the area over. So it always starts at 0. And it's going to go to whatever the price is, whatever the quantity is. So let's call it Q plus, say, for example. It could be Q plus, it could be Q star or whatever. It's whatever so let's call it QM. So it's the quantity that the market distributes. All right. So we've got an integral, we've got the bounds, we know it's a dq, so we need to know the function. All right. But it's a difference of two functions, right? So it's going to be on top is the demand curve. And of course, D is a function of Q minus whatever the price is. Let's call it the market price there. So that's always going to be this area here. It's the area between the demand curve and whatever price the market is at. The producer surplus, again, is going to be the same bounds of integration. Right, but it's now going to be the market price minus the supply curve. So it's going to be the area between whatever the price is and the supply is. And the gains from trade is going to be the integral between 0 and however much the market does. It's going to be the difference between the demand curve and the supply curve. So the whole point of this is just the mathematical explanation of this. This is just turning these words into a formula. And you notice, of course, that this plus this equals this, right? Because it's the same bounds. So we can put it together. It's over dq, so we can put them together. And it's going to be equal to this plus this. And dq minus sq, and the prices doesn't really matter. That's kind of, because the price just determines whether the gain goes to the consumer or the producer. Okay. Let's do a couple of multiple choice questions. Which is the following is a source of $20 of consumer surplus? So which one of these four? It's B, right? So that's right on what consumer surplus is. So consumer surplus happens when a consumer is willing to pay a higher price but gets it for a cheaper price. So it is a benefit to the consumer of $20 of money that they've saved. All these other situations, nothing to do with that. Okay, which one of these is the $20 of producer surplus? D? Yep, exactly. That's exactly what producer surplus is. It's kind of like extra money. They were willing to sell it for $100, but able to sell it for $120. So it was $20 surplus to their expectations. That's what we mean by produced surplus. Again, all these other things, not it. Okay, so here is the demand curve. So approximate the equilibrium price if Q star, if the equilibrium quantity is 80 and the consumer surplus is $10,000. So I guarantee you have enough information to so let's do a little bit of, here's the demand curve, here is 80, and here is 45,000. And the consumer surplus is 10,000. So where do I put the 10,000 on the board? So yes, so here is, this is what we want to find out. And so this is 10,000. This area is 10,000. So this leg here is 80. If this leg here is 80 and this area is 10,000, what is this leg here? What's the area of a triangle? 1/2 base times height equals area. But we know the area is 10,000. We know the base is 80. Can we figure out the height? Right, so 2 goes into that 40. 40 over here. 250. Okay, so if this is 250, what is this price equal to? 41,700. Yeah. Okay, so this is quite a tricky problem. You have to really sort of go into the logic of it all. Right, so the main thing was realizing that the surplus is an area, which meant that you could figure out what the dip in price had to be.
Would that be impossible to do one like that if it were like actually curved and you had to do the integral of it?
Then it would be harder. But if it was something that you could integrate, so for example, if it was a function like, what could be a possible function? Could be a function like 45,000, let's say e to the minus 0.1 cubed, for example. Right? And then you would have enough information. It'd just be a longer problem. But the thing is, instead of using half base by height, you would be doing this integral here. Okay. And so you'd have to solve, so you get some equation with exponentials in it that you'd have to solve. But yeah, you could do it because the basic idea is, if you know what this curve is, you know this area, so you can you can figure out what this is, so you can figure out what this is. So it's like a logic chain to get the answer. Or else you could also have looked at the problem and could have said, this is ridiculous. The price is underneath it. Could it possibly be these? No, right? Because if the equilibrium price was that, then the consumer surplus would be basically 45,000 times 80. So these three things are all ridiculous. So you could have just answered the question just by doing that. So even if it had been like a curved line, that you could still do that. So yeah, you just had to know what's happening. Okay, here's another problem. Now we're given a supply curve. So these are probably actually the kind of problems that you would have been given, because this is a straight line problem. Estimate the producer surplus. There's no trick to this question, right? Because this is just asking for this area. It's a triangle. So, Matt, what did you get? Oh, I saw you.
So Q equals 30, that means the line on the top is 30. Both of them.
This line here is 30. This line here is also 30. 450, yeah. This line is 30 from here. This line here is 30 because that's the difference between 10 and 40. 30 by 30. So this whole rectangle, or this whole thing here is 900. It's a triangle. At top of that, it's 450. Okay. So here is a question about what happens if we're trying to do an artificial price. Okay. So we see that the equilibrium price is 100. No, it's 95, is it? Oh yeah, it's supposed to be a little bit over this side, okay? Doesn't look that good, but anyway. To a price of 110, what's going to happen? Well, if the price is 110, oh, sorry, yeah, sorry. I'm talking about, here's P. Yes, that is definitely 95. That's 100 is what I think. So the total gains from trade, right, is this big triangle here. What happens if we artificially change the price to 110? Then this is the price. That means there's only going to be that much demand for the good. Even though there's more supplied, that's the amount demanded. So then we cut off here, and this is the gains of trade right here. So the difference in gains of trade is this little triangle here. Really want to color in that triangle. So let me do that over here. Let's see if I can. So we want to figure out what is the area of that triangle. Okay, so here is 100. Here is 110. So we need to know what this point is, right? We need to know this, and we need to know that. So if the price is 110, how much is the demand? How much quantity is exchanged in the market? You want to read that? 80. So we look at, again, we look at the 80, we come up here, and we get this point here. And so what is the price that's put with that? It's a little bit above 80. So that would be 90. So maybe 85, let's say. Something like that. Can anyone tell me what the answer is without even having to do the, it has to be A, right? Because here, this is something like $20. This is something like $25. We're not going to get thousands of dollars from this. I think that we can do that for today.